Hello everyone, welcome back to Math 1350, more on math. This topic is Chapter 7, Section 3. Section 3 deals with repeating decimals. By the 7th grade, the students should be able to convert a rational number to a decimal by using long division. Also, they should know the decimal form of a rational number that terminates in zeros or repeats. So, what does that mean? Well, earlier we saw 7 over 8. We broke down 8 into 2 times 2 times 2. And so we saw that we needed to make it repeating a terminating decimal. We needed 5 times 2 is 10. They both had to have the same exponents. So we have 10 to the power 3, 7 times 5 to the third. And we got that, remember, work it all out, we get 8, 7, 5. It's terminating decimal. Or, that's one way of doing it. We should also be able to teach the kids this method, long division. Does 8 go into 7? No, so we put a decimal. If we put a decimal there, and we can put a 0 there. So 8 goes into 70 8 times. Plus 8 times 9 is 72, too big. So 8 times 8 is 64. Now we subtract. 4 minus 0 you can't do, so you have to borrow 1. 10 minus 4 is 6. Now for every number we're looking at here is going to be another 0. So 8 goes into 60. Well, 8 times 8 is 64, so it has to be 7. 8 times 7 is 56. Subtract those, we get 4. Okay, now we're looking at the next number. 8 goes into 40 5 times. 5 times 8 is 40. No remainder. That's what we're looking for. Once we have no remainder, there's our answer. And you know, it's the same thing. Alright, but let's look at now, that was a terminating one. Let's look at non-terminating. 2 over 11. So 11 goes into 2. It doesn't, so I put a decimal. That makes it a 20. 11 goes into 20 once. 1 times 11 is 11. Subtract them. I get 9. So the next number is 11 goes into 90 8 times. 8 times 11 is 88. Subtract them. Get 2. 11 goes into 20 one time. 1 times 11 is 11. We get 9. 11 goes in 98 times. So we see a pattern forming here. It's going to keep on going. So instead of writing all that, since it's always repeating, we write it this way. This is called 1800ths bar. That means anything under the bar repeats itself. forever. 0.18, 18, 18, 18, forever. So if it's not terminating, we'll see if it has a repeating pattern. 2 over 13. So does 13 go into 2? No. So we put his dot there, which makes it as 20. Let's work this one out. So 13 goes into 20 once. So 1 times 13 is 13. Subtract them. It becomes 7. 13 goes into 70. 6 would be 7. So it would be 5 times. 5 times 13 is 65. $13 goes into 50. 4 times 52, so it's 3. Three times is 39. Subtract, we get 11. 13 goes in 110. Not 9, so it's 8 times. 8 times 3 is 24. 8, so 104. Subtract them, I get a 6. 13 goes into 60. 4 times. 4 times 13. 52. Subtract it, I get an 8. 13 goes into 80. 7 times, that's too big. 6. 7, so it's 6 times. 6 times 13 is 78. Gives me a 2. 13 goes into 20 once, which is 13. Subtract that, we get 7. And now it seems like we're repeating that. So it's going to be these numbers repeating. So that's the answer to this question. 0.153846. Okay, how about, doesn't have to be all of them. Some could just be a partial set of them. 5 over 18. 18 goes into 5, it doesn't, so I put a decimal, which makes it a 50. No, so it's got to be 2. 2 times 18 is 36. 8 goes into 140 7 times. 7 times 8 is 56. 7 plus 12. Subtract. So I get 14 again. So you see I'm in an endless pattern here. So the answer here is 2.7777, which means since the 7s repeat, the bar only goes on top of the 7. Yeah, so the repeating part only goes, the bar goes over the repeating part. Since the 2 only doesn't go but once, it doesn't go over there. Be very careful where you put that bar. It changes the answer. Writing repeating decimals as A over B. For example, if I give you, let's say n, the number I'm dealing with is 0. It's repeating. So let's see what that one's going to be. So since I know that n is 0.33 and it's repeating, if I multiply by 10, if I multiply this by 10, then I'll get 3.33. So if I multiply it by 10, I get 3.33. That's a mistake. So if I subtract them, what happens? 10 minus 1 is 9n. What happens here is these two cancel out, no matter how long they are. So I have 3 minus 0 is 3. Divided by 9. This simplifies. So this answer came from that question. So 1 over 3 is equal to 0.33333. Or I should have wrote 0.3. Okay, let's look at another one. Let's say we had 0.235. That's my n number. Remember, like we did up here, since these are all the same numbers, I should have had n equals 0.3. So when I multiply it by 10, I'd have 3.3. That's easier to see. So since it only repeats once, I multiply by 10. Since this one has 3 of them, then I have to multiply by 10, 100,000. If I multiply by 1,000, then these 3 numbers go in front. And everything else, the repeating patterns, go behind it. Subtract, these cancel. So 1,000 minus 1 is 999 equals 235. Divided by 999. So n is equal to 235 over 999. Whatever that answer is going to be. Alright, now a more complex one here. Let's say the n I had, it was a 2.345, and only the 4 and 5 repeated. So n is equals to 2.345, and those repeat. If I multiply by 10, then I have 2, 3. When I multiply by 10, I just move the decimal place over. But the problem is I still have that 3 there. I can't just subtract them. So I have to make it so it's a repeating pattern of 0.45s. So I have to 1, 2, 3. So I have to multiply this equation by 1,000, 3 spaces. That'll give me 10n equals 23.45. 1,000n. So again, I'll move it 1, 2, 3. So it's 2, 3, 4, 5 decimal 4, 5. Because I had to go to the very end. So now when I subtract them, I get 2, 3, 4, 5.45 repeating minus 23.45 repeating. So these cancel. 5 minus 3 is 2. 2, 2. So I have 2, 2322n equals, no, oops. This is 2322. 1000 minus 10 is 990. Plus 1000 minus 10 is 990. So I divide 990 in both sides. I get n equals 2322 over 990. And you simplify that how you want. All right, let's try the homework.